today I'd like to talk to you a little bit about streamside vegetation, and by this I mean the trees and the bushes that are growing along the banks of our rivers, and how that might affect the water temperature of the river that it's nearby, and in turn what's the implications of this for the trout living in these streams. So a bit of a story going through there. This project was particularly interesting to me because I'm a very keen fly fisher. I love getting out and hitting the streams. So you go across New Zealand, obviously you get a few really nice big browns over there. But I really cut my teeth learning fly fishing in the rivers of the Upper Goulburn, the Stevo, the Taggart, the Acheron, up around Marysville there. And here's a trophy trout from the Taggart. I'm sure many of you have caught a fish, probably not as big as this one from up there, but there is a lot of little fish up there, but it's great fun fishing these waters. Okay, so onto a bit of technical stuff. Many of you, I'm sure, have heard this word riparian zone, and you probably know what it is. Those of you who don't, I'll just sort of provide a brief description of what we're talking about. This riparian zone is the narrow strip of land either side of a watercourse that has an interaction with that watercourse. Likewise, this vegetation interacts back with the stream itself. So it's not only the stream influencing the vegetation has a role to play in what goes on in the stream. So you might hear these terms about what we term a healthy or an intact riparian zone. Lots of good trees, native vegetation coming down to the stream bank. Here is a much more modified landscape. We could perhaps call an unhealthy riparian zone. There's obviously farming occurring in this area. The understory is being cleared. We've got some remnant gums along this creek line, but the riparian zone looks very different to what we see over here. So this begs the question then, how does this streamside vegetation, this riparian zone, how does it influence the trout in the river and what's going on there? Firstly, streamside vegetation plays a really important role in providing the habitat in the stream. So you're all well aware that when you've got dead branches or an old tree falling in a river, this causes snags, really quite complex woody debris. It's fantastic trout habitat. It's also important in terms of the food for trout in these systems. So all trees, and eucalypts especially, they're going to drop leaves and they're going to drop bark. And that becomes a really important food resource for the animals, especially the invertebrates that are living in that stream. There's little shredders and little nymphs and all sorts of things in there eating these organic material, and that in turn becomes trout food. And stream vegetation also plays a really important role in shading the stream, and this then influences the temperature regime. So why is temperature important for trout? Well, as you're all aware, trout like cold water. They're cold water species, and when they find themselves in spots which are a bit hot, they don't like it too much. What stops trout growing? And there's this sort of magic number, give or take a little bit, of about 19 degrees, which is this upper limit for when trout will grow. They like it cooler, and that's when you're going to get bigger growing fish. There's also these lethal limits of temperature. So it gets above 24, 25 degrees, and it remains there for a prolonged period of time. It gets acutely stressful for fish, and you can actually get fish dying. So when the waters get too hot, fish disappear. But as Jay showed you earlier on, the waters can get above these time periods for short periods of time during a day, and that might be okay. It might be locally stressful for the fish, but if it's going to cool down at night, then perhaps the fish can find some refuge, but they're not going to be growing very well, and they're going to be under sort of overall stress for a period of time. So, shading does keep the water cool. This is a study coming out of the UK, but it's directly applicable to here in Australia. It's directly applicable to the US. On the x-axis along here, the bottom axis, we've got time. This is the northern summer, so we've got some dates in July 2006, and these researchers went out and they measured water temperature, and they measured the water temperature in a pool with no shade, the blue line, and a pool with shade in the green line. We can overlay some of these critical thresholds that we've talked about, and we can see that this unshaded pool, the water is consistently getting into this potentially lethal zone of temperature. And if it remained up there for a prolonged period of time, we might expect to see trout being adversely affected. Whereas a shaded pool, often the temperature is actually below this critical growth threshold here. So we're seeing that shading keeps the water at a temperature that's cool enough to allow trout to grow and persist. So shading is important. But, and this is a big but, the water temperature that we observe in the pool or a riffle or a run at the bridge when we go fishing is not dependent solely on what the vegetation is at that spot. And the key thing to remember here, especially in trout streams, is that they're generally flowing. The water flows downstream. So what we observe at the point where we are fishing right now is dependent on what's going on in the catchment upstream. Yes, there's some influences of what's happening on the bank either side of me right now, but a large part of the effect on the water temperature where I am now is a result of the legacy of where that water's travelled. That's an important thing to take home. And some of these other issues that at a landscape scale level that perhaps is good to think about are things such as broad landscape land use change. Is it agricultural land? Is it forestry? Has there been forest clearing? Has there been active willow management occurring in the area? What's the local climate? Are we seeing, is it summer? Is it winter? Is it a hot day? Is it a cool day? How much water is going down the river? So those of you who have got a kettle at home, which I'm tipping is probably most of you, what happens when you put one glass of water in a kettle and you turn it on? It boils pretty quickly, doesn't it? When you fill the kettle to the top, it takes a lot longer to boil that water because the capacity of water to warm, the more water you've got, the longer it takes to warm up. So small streams and streams with low water levels and drought periods are going to be really prone to getting warmer a lot quicker. Topography is important. This is the terrain. Is there a gorge or a mountain that's going to provide some shading on the stream that might help keep that stream cool, or is it flowing through a very flat open area that means that it's very prone to getting heated up? And also channel orientation. Does the stream flow from north to south or south to north? Is it flowing from the east to the west? And I'll talk a little bit more about that in specific reference to the Upper Goulburn area in a minute. Okay, so given these sort of different drivers of what's happening on stream temperature, this role of vegetation, we know shading does have a role, but these other more broader landscape scale things, how can we sort of balance out what's going on? And here I'd like to talk about what's happening in the Upper Goulburn trout fishery and seeing has changes in the riparian area, not only at the local scale, but also at a regional scale. How might that have affected the trout fishing that was on the trout fishery that we all know and love in this area? I'm particularly interested in looking at the role of willow removal because there's a lot of concern around willow removal. It can be quite visually disturbing in a sense. You go along your favourite stream, you've always known and loved how it is, you turn the corner and there's an area where willow removal's occurred. And it does look like a bomb's gone off there sometimes. But it's good to think about this process of going from willows to willow removal and re-veg, and here you've got sort of 5 years after the willow's removed on the Acheron River here, you've got 10, 15 metre high native trees replanted there. This is not always the case, but there is often a plan involved, and we're going to see Mark's going to talk a little bit more about this from a catchment management authority perspective later on in this session. Okay, so where are we? Well, this little yellow area, we all know where we are. We're in Mansfield here. This is Lake Eildon. Basically, this yellow area is what we call the Goulburn Broken Catchment. And this is the area which is managed by the Goulburn Broken Catchment Management Authority, and the state is obviously split up into these various CMAs. And so we're looking at what's happening in the Goulburn Broken CMA, in particular the upper reaches of this and these trout streams above Lake Eildon. And again, a little bit more of a map to orientate where we are. Here I'm going to focus mainly on the Dalatite, the Halqua, the Jamison and the Goulburn. There's Mansfield there. I'm going to look at what's happening in these streams. When I looked at this map, the first thing I thought about was orientation. The Dalatite and the Halqua are rivers that are flowing from the east to the west along their whole length. The Goulburn River is flowing from the south to the north. Stream orientation plays a fundamental role in determining the temperature regime of that stream. The sun rises in the east and it goes across the sky. If your stream's flowing east to west, all day long that sun is above that stream, baking that stream until it sets in the afternoon. There's very little interplay of riparian vegetation shading that stream, or less capacity for it to happen, because the sun's always, in summer especially, directly above that stream channel. In the Goulburn River, however, the sun again rises in the east, it doesn't change there, but in the morning, as the sun's up here in the eastern sky, any vegetation that's on the eastern shore of that stream is providing shade onto the stream channel. Midday, yes, the sun is directly above the stream channel, it's getting hot. Well, here, you've got some nice trees growing on the westerly bank of the Goulburn. So in the afternoon, that riparian vegetation on the westerly bank is actually going to provide some shade and ameliorate some of that effect. We're not talking about any management intervention going on here at all. This is purely just the orientation of these streams. And in this case, the Dalatite and the Halqua are naturally prone to getting hot compared to some of these other systems. So that's something important to remember. We can now think about, well, what's going on more broadly in the catchment? Where's the vegetation? So here's a map of tree cover in the Upper Goulburn, and we can see that there's large areas of bush up here, especially in the upper reaches of all these systems. So all those lovely little headwater streams that feed these larger rivers, naturally or generally, they've got some tree cover along them, and it keeps them nice and cool. They're well shaded. This acts like a refrigerator for these systems. It keeps that water cool when it falls and it's seeping out of snowmelt off the top of Mount Buller, keeps this water nice and chilled, and allows it to stay cool further down the stream. Again, as Jace mentioned before, what we see in the Delatite, however, is we've got this large area of cleared land. So about Merrijig, where it comes out from the forest or thereabouts, it comes down to a flatter farmed area where there's a lot of cleared vegetation. There is still some vegetation on the stream itself, but more broadly in that area, there's no trees. And you know when you walk into a forest, it's generally cooler, isn't it? Compared to when you're out in the middle of a paddock. And so that local climate is affected by the general land use. So we're seeing here that there's some differences across the landscape in the level of tree cover that's naturally there. Willows. Okay, willows are an issue from two sides. Some people love them, some people hate them. So where are the willows in the system? So we've got good mapping data of where the willows occur. And in pink here, I've listed where willows are known to occur along these rivers. So you can see right along this lower Delatite area, there's quite big stands of willows along that channel length. We see that there's some willows around Jamison here on the Goulburn and a little bit around Halkwa there. So there's patches of willows in this landscape, but there's still large patches of native vegetation. Well, willow removal is an issue, isn't it? Well, potentially it is. So here we've got some data from the CMA showing you where willows have been removed on these areas in yellow. The pink is where the willows occur, and the yellow is where active managements occur to remove the willows. Now just to remind you, willows are removed because they're a declared noxious species, I think, but they're removed for a number of different reasons because firstly they can get into the stream and choke the stream up, and they can fill up all the gaps amongst the stones, which affects habitat for small invertebrates. They can also cause the stream to get a lot shallower and cause the stream to get braided, which causes increased flood risk and also affects the amount of water that's lost from the stream. Also, the willows drop their leaves, and that does provide some food for bugs, but it's nowhere near the same quality food as native vegetation leaves. We've got Australian bugs here in our streams. We've got European trout, we've got Australian bugs. We don't have European bugs living in our streams. Our Australian bugs like eating Australian vegetation. And so, as a food resource, native vegetation provides a better food resource for our things. So there's a number of different reasons why willows are removed, but we're going to put that to one side. That's not what we're going to talk about today. What we can see, though, is that willows have been removed, but it's been by nowhere near all willows have been removed in these areas. And it's quite patchy where they've been removed. And it's generally in these lower reaches of these systems is where the willow removal has occurred. This is already areas that are potentially prone to getting hot in the first place, and potentially already marginal trout habitat. Okay, so it's good to think about willow removal. That's something that we're doing. What's another big landscape scale change that's happened in this area recently? Well, unfortunately, we had very big bushfires in this area in 2006, 2007 that burnt massive areas of the upper catchment of these streams. So in pink here is the area that was burnt by these bushfires. And as you can see, all the headwaters of these streams got burnt to varying degrees. And we know that the fire severity that was in these burns was most intense along the river channels, around the valley floors. And this meant that we basically toasted all the riparian vegetation that was in these systems along these small headwater streams. All of a sudden they were open up to getting sunlight hitting them. Now remember back to the kettle analogy, these small streams, they're already prone to getting hot very quickly. If you remove any shading they've got, they get hot very quickly. So we've got this loss of canopy cover right across the landscape. And I've put it here in relation to what's happening with the willows. We see the willows are these yellow dots. You compare the yellow dots to what's happening in the pink there, we can see the bushfire in this area has probably had a much greater effect on changing riparian vegetation than willow removal, at least in this circumstance. And just to show you what this looks like, here's some fish survey work we did after the bushfires. You can see that along this stream channel here, where once there would have been all this nice forest occurring, all that vegetation has been lost. Now there's fish here, there's blackfish, there's trout, but the water temperature is much more prone to getting hotter quicker because we've lost that native vegetation and brought about by fires. Fire not only affects the shading on a stream, it also has these more perverse downstream effects. So whilst Black Saturday bushfires in 2009 didn't burn this area directly, it did burn up around Woods Point. And as we saw from Dan's talk earlier on today, where you've got a burnt catchment and you get big rainfall events, you get these sediment slugs and ash coming into the system very quickly. So this is 6 months after the bushfires, and here we see the Goulburn River on both sides here on the right. This is where it joins the Halkwa, this is where it joins the Jamison. And hopefully it's clear, you can see that there's clear water coming out of the Halkwa, clear water coming out of the Jamison. You've got this chocolate soup coming down the Goulburn. So again, bushfire can have pervasive effects on the stream. This not only clogs up the water, it reduces water quality, but all that silt and all that ash fills up all those nice little gaps amongst the rocks, which is all the home for the little stream invertebrates. It smothers the stream bed. It removes the food resource, and it means that that trout fishery takes the hit for a while. It will recover, but it does take a localised hit. What's happening in the weather? This is air temperature data from Mount Buller. So this is up on the top of the catchment. And we've got, through time, we've got 30 years of data here, and we've got the mean maximum January temperature. How hot does it get in summer? This is when we're all out enjoying our nice fishing on our summer holidays, but this is also the hottest period of the year. So how hot does it get? Well, what we can see in this first 20 odd years of the data set, the average summer mean maximum temperature was about 16.5 degrees. Okay, this is not the maximum warmest temperature. Obviously, there's going to be days when it's warmer, but this is the average temperature. So it's average about 16.5 degrees in this period. However, over the last 10 years, it's been about 2 degrees hotter on average in January. This is significant. This is a very big increase in air temperature, and there's a very strong relationship between air temperature and water temperature. So the climate has been warmer during this period, and that's going to influence the temperatures in the streams and have an effect on trout. And in particular, these years where we thought there was some quite poor fishing, 2013, 2014, we can see that these Januaries were some of the hottest on record. So we've got a climate predisposed to already being hot that's going to have an impact on the fishery. What about river flow? Well, this is what we call a hydrograph. This is a plot of how much water is going down the river, and here I've plotted up the water going down the Delatite River. We've got time here, so we've got some data from 1960 right through the current day, and we've got a measure of how much water is going down. This is megalitres a day. Don't worry about the units too much. But what we can see is that each of these little blips here is a winter. And so there's some really wet winters, like back here in the mid-70s, and more recently in about 2010, but there's also some really dry winters as well. Well, you can say, well, what's the historical average? And we as scientists often use this period, 1960 to 1990, as a historical average period, a reference period. And we can see that there's about 320 megalitres a day on average going down the river in this time period. What's happening more recently? Let's walk towards the millennium drought. This is that horrendous period of really dryness we had from the late 1990s through till about 2009, 2010. And we can see that there was actually a 40% decline in stream flow going down the river during this period. It's very, very dry. 40% less water going down the stream. Again, remembering the kettle, less water warms up a lot quicker. What happened over the last 10 years? Well, even though we're spanning half the drought to the present day, we still see that flows are about 30% below the long-term average, so it's still dry. What if we go to the last 3 years, over this period where we know the fisheries had this hit? What's happening? We're 33% less water in the stream compared to the long-term average. So those of you with long memories reflecting on back what fishing could have been maybe back in the 80s, in the 70s, those of you who've been fishing the area long enough, it's important to think when you make those comparisons, they're very real and it's a real observation, but it's important to think how the environment has changed during that period too, to put some context around the observations that we make. So there's less water going down. So what does this all mean? What does this mean for willow removal? What does this mean for more broader landscape scale change in this area and the trout fishery itself? Well, it's important to acknowledge, and you all here know this, and you're dead right. Like all riparian vegetation, willows do provide shade. They are keeping the stream cool. They are providing some branches into the stream, less so than gums, and their root masses can provide some habitat for trout, and they are dropping leaves in there that do provide trout food. And therefore, willow removal on a local scale can be detrimental to trout. You fished there yesterday, there was a willow, you caught a brown off the back of that bubble line coming through the willows there. You go there tomorrow, someone's ripped that willow out, that trout's probably not going to be there. Yes, willow removal has an impact on the local scale. But it's very important to put this into a river scale, because when we talk about a fishery, we're not talking about one fish next to one log. We're talking about fish in a population across the catchment. And on a river scale, the impact of willow removal really pales compared to these other more larger scale changes that have occurred in the catchment in this area. And I make this judgment based on the fact that there hasn't been enough willows removed in this catchment to have had a large pervasive effect on the fishery. And where those willows have been removed has only been in the lower reaches. And this is not in the areas where we expect to be a major effect on stream temperature. Because remember, what we observe is manifest on what's happening upstream. And if we're removing all the willows downstream, well, and the water's getting warm, That's because something's happening upstream, not because we've removed willows on a local level. Although it does have some effect, but nowhere near enough as things such as fire, drought, these record temperatures that we've observed, and this intrinsic nature of our channels, that they're all flowing east to west. They're naturally predisposed to getting hot. And when you've got these record temperatures and low flows, coupled with the bushfire, unfortunately it's a bit of a perfect storm for making conditions that are quite bad for trout, at least in the short term. So it's important to remember too, so whilst willows are removed as a management activity, it's important that they're replaced with adequate native vegetation that's going to have a shading effect and have a replacement effect quick enough. I'm working with a Golden Broken CMA on this, and we're doing some pretty fancy modelling. I thought I'd make some pretty pictures for you here. What we're doing is we're using some really cool data sets that are out there on vegetation, on the landscape here, and using this to inform willow removal and revegetation plans with a real keen eye on reducing the impact on stream shading and actually maximising or minimising that increase in temperature across the landscape. The way we're doing it is we're using these things called digital elevation models, a DEM. We basically fly a plane with a radar or a laser, and it flies across the landscape and takes really fine scale elevation measures. We can make these pretty cool 3D maps here of an area. Here we've got the river channel going through here. You might be able to make out there's a road. It's really fine scale detail of the elevation. We can then overlay a solar radiation model. We can say how much sunlight's hitting that stream when the sun's at the sky at various times of the year. And what's the role of riparian vegetation? We've got good, really detailed maps of where vegetation is. How much shade is that tree giving us? There's a patch of willows there. If we remove that willow, how much extra sunlight's going to hit the stream? Okay, we're going to replant that. What's going to be in 5 years' time when the trees grow? What's going to happen in 20 years' time? So hopefully this becomes a tool that allows river managers to really prioritise where they do their actions and also where they do the revegetation and willow removal to ensure that stream temperatures and the impact on stream temperature is minimised to benefit our trout. And thank you all very much for your time.
Authorised by Victorian Government, 1 Treasury Place, Melbourne.